Getting ready for day 3 of Advent to Code. We have about 1 minute left. As far as going over day 2, I thought about this a lot. I think there's something that eludes me. Like, I really didn't like the hard coding that I did for all these numbers. And I thought about how to do something like this to potentially solve the problem. You could do something similar where you convert all the A's, X's, like all of them to numbers. So you could do like basically this whole thing like this. And then you could compare just the numbers to see if they're the same for a draw condition. But you'd still have to hard code the win condition, which I guess, yeah, you still have to hard code the win conditions and the lose conditions if it's not a draw. So it brings down the possibilities to only 6. Anyways, I still think like the code doesn't end up becoming that much cleaner. So I'm stuck on like a really clean way to solve it other than hard coding, and it's only 9. So I figured we'd just keep it. Anyways, let's go. Day 3. Here we go. All right, so we have this input here. Okay, so all elves made a list. Okay, so the letters represent items. Following list is 6. Okay. Every item is identified by a single lowercase number or uppercase. The list of items is given on one line. Oh, there's two compartments always. So basically, you always split in half. Okay, so each line is a single sack, and we're going to split that line in half always. So the first thing we're going to want to do, as normal, we're going to get our lines equal puzzle input split lines, and then we're going to go through. We're going to do that again, and that's going to be, we're going to split it in half. So we're going to take first and second is going to equal line. Let's see, what would that would be basically to line dot length. Yeah, the length of line. Can you partition a list in Python? I wonder. I mean, it's a string. I don't know, but you can do this. Length of line divided by 2. We're going to go 0 to that point. And then we're going to do length of line divided by 2 to the end. So this is line. Okay, let's print first. Let's do this. Just to make sure that the variables are correct. I just want to run that really quick. Okay, so does this match the problem so far? The first is WR, second is FP. Okay, so this is SL. So GL and then R. Yeah. So this looks correct. It looks like I'm splitting them correctly. Okay, so I'm splitting those lines correctly. And now what we want to do is find an item that is the same in both. Okay, so now that I have first and second, I can just go through for every character in first, we're going to say if character in second return, we're just going to print that character. Okay, but what do we do with all of them? So we get, let's just do that. Let's just do enumerate, which gives us the index here. Just because I want to print the index like that. You might notice the UI of my editor has changed a little bit. PyCharm just updated their UI. So we have, let's see, PLL. Wait, why are we... Okay. So we found it. Okay, but this... Okay, here we can do a continue because we've already found it. So let's just try that one more time. That's weird. How are we getting it a second time? So the index... We've printed the index, and then we're continuing the inner loop. Okay. Yeah. Python doesn't allow you to break out of the, I don't think so. I don't think you can break out of the other loop like other languages can allow you to do that. Okay. So, yeah, it doesn't matter right now. What am I supposed to do with it? So let's see, we have PLPV. So that looks like over here, PLPVTS. Okay, so our answer is correct so far. What do we do with that? Lowercase items have priorities. Okay. So we sort them, lexicographically sort them. And then we sum the integer value. Okay. So, what we're going to do is, let's see, for a character in first, we found it twice, so it exists twice in the second. Yeah, it exists twice in the second. We'll just add it to, it might not be a set, darn. Yeah, I'm just trying to think how we undo this duplicate. I think the easiest is we just write a function here. So, define find. We're just going to pass in first and second. For char in first. Yeah, this is the same code here. So we can literally just take this, except instead here we can return character. Now what we're going to do is dupes is an array. We're going to call that. So dupes dot append find dupe of first and second here. And then now that we have dupes, we're going to sort it. So we want to sort, so for letter in dupes sorted of dupes, we're going to get the letter dot lower, and then we're going to minus, we're going to turn it into an integer, and we're going to subtract that from the integer of the lowercase a, and that should give us our value. Our sum is 0, so we're going to do let's see, sum plus equals val, and let's print that letter and val just to make sure we're doing it right. And then we're going to print our sum. Okay, so let's see what that does. Int with base 10L. Okay, so we turn, let's see, Python character into int. No, I want the darn, I want like the ASCII code. Yeah, maybe that's it. Is it ASCII? This is something I do so rarely. Okay, so how do we do the opposite? Ordinal? Okay, ordinal. So I get ordinal, and I subtract that. What does that give us? Okay, so let's see if this is right. Okay, so P should be 16. I have 15. L is 38. Oh, they keep going. So they're not, okay, so I don't need this lower. And apparently this is +1. Okay, let's try. So why isn't it not sorted correctly? We should have the lowercase p first. Dupes is, oh, apparently, let's see, oh, higher is more. Okay, so apparently in ASCII, uppercase is more, so we have to do sorted where key, that's going to be tricky. So we want to potentially flip everything. So, okay, so what we can do here is before we append it, is lower. Lower if char. Okay, here's what we're going to do. If char is lower, we're going to return char upper. And else, we're going to return char.lower. So we're kind of flipping them, kind of intentionally. It's going to make our output worse, but it should be, it's not, it should be uppercase p, lowercase. Okay. Yeah, okay, so 1 through 26. Oh, we don't really need to sort them. Okay. This is, yeah, sorting is kind of a worse, useless. So this is kind of dumb. But what if we did this? I'm just curious what that gives us. So the P is 15. L is 43. Yeah, this isn't right. So let's just find... So let's just return char here so that our return is cleaner. And what we're going to do here is say if letter is lower, then val is letter minus a plus 1. That's actually better if it's b then, right? I don't know. Actually, that makes sense. But yeah, we'll just keep that. else val equals the same thing, except this is a capital A, and instead of 1, we're going to add 27, because A should be 0. Okay, so now we don't need this plus 1 here. So 16, 38, 42, 22, 20, 19, sum is 157. Great. So let's try that here. Let's see, our puzzle input. Let's try it on our puzzle input. Let's go back here, get rid of the test, and we're going to run it again. So this is supposedly our sum. Let's try that out really quick. That's right. All right, part 2. What do we have to do now? So let's go back to our test. Okay, so part 2. Only item type carried by all 3 elves. Within each group of 3 elves, okay, so every set of 3 lines is a group. Each group can have a different badge. So in the above example, the first group's rucksacks are the first 3 lines. Okay. Okay, so there is a Python iterate in groups of X. It's a functools, I believe. No, I don't want a data frame. itertools. It's Python itertools. There's some fancy things here. Chain, compress, drop is pairwise. No. Darn, I don't remember which one it is. Yeah, because slicing will give me every third, but it doesn't. Yeah, it doesn't give me. Okay, I'll just have to do this the old-fashioned way. Okay. So. Okay, so this is part 1. I think we're just going to start over with this guy. Okay, so what we're going to do here is group equals 0 if index is divisible by 3, then group equal. Anyways, we're going to reset the group. Okay, so that gives us every 3. Lowercase r appears in all 3. Okay, so we don't need to do the splitting anymore. We're just looking for what's between it. Okay, so this is find common, and else we're just going to add to the group list. Okay, group list. Okay, so it's going to start at 0. We're going to say, actually, this is even easier if we do this. We don't need the index. We're just going to say if length of group list is 3, so we've already done 3. Now we're going to process 1. Okay, so what we're going to do here is do the processing. So for I'm going to call it groupie because I think that's funny. So for each groupie and group list, we're going to go through the characters. We're probably going to want a function for this one. So find common in a group. So there's always 3, so we can just say 1, 2, 3 equals group list. So we don't need this one. Yeah, for okay, there's an easier way here. Rather than doing a huge loop, order doesn't matter. So all we need to do is basically put them all in a set and find the intersections. Okay, so what we do here is 1, 2, 3 equals and 3, and then you can do intersection, so 1 intersection of 2, and then intersection of 3, return result, and then we're just going to print that result so far, find common of group list, and then we're going to set group list to 0. Then we're going to append our current one, and then we need to do this one more time at the very end. Okay, and let's just, yeah, so... Okay, so that's part 1. Part 2, we have R and Z. So R and uppercase Z, that's correct. So those are the correct answers. We actually only need the first item there. So we're just going to pop it, R and Z. We still want this, how we get the value. Okay, so we're going to say, basically going to do this part again. Okay, so instead of printing, we're going to say results. Did I call it results before? No. Results append. Okay, and then here we're going to go through results, and we're sum2. Okay, and we still need to do that one more time and append it. So results append group list. No, this is called find common of group list. Okay. What do we get? So sum 2 is 70, and then I don't know why we're doing that. Okay. 70, and it should be 70. Great. So let's try it without our test. 2738. Boom, that's it. So there's day 3. Writing this method here, find common, I feel like would have actually been somewhat complicated if we did it in a for loop. But because we were able to use the set intersection, it made that a lot easier. I think that the other way I was thinking about doing it, but I decided not to, is you could turn all the letters into numbers first, like we do here, and then you could store it in an array. So you could basically just say, if this letter is found, we have a bit array, so zeros and ones in an array. And if that letter is found, you set the bit at that index to 1, and then basically you can do bit shifting to take all 3 arrays, and you can find where the ones line up. Because, yeah. So you can basically do that. It's the same thing. It's a little easier to write in Python with the set intersection stuff. So with that. But yeah, you could do bit arrays and binary operators to do that as well. That would also help you in problem 1. It just prevents this for loop here. You could do it in problem 1 as well, because once you split in half, you only need to find duplicates. So you could do that. If they made this a little more difficult, like a much larger input, then these for loops would be a little too slow and you would have to do it that way. But yeah, I think that's good. So